And I say, wow, omega-3 are able not only to improve brain health and your cardiovascular health, but also your gut.
What happens when we eat a high-fat diet exactly?
Not only a question of quantity, but it's also a question of quality. The Inuits, they were eating huge amounts of fatty fishes, really low at cardiovascular risks. But they moved from Scandinavia, and after several generations, people started to have the same level of cardiovascular disease than the people living in Sweden. So they were not genetically protected, it was the food that protected them. Fatty acids could also induce leaky gut, which induce chronic low-grade inflammation that favor the insulin resistance and at the end type 2 diabetes.
You say the good fats. What are the good fats for the microbiome?
A resolution of inflammation effect, which is really different for just the anti-inflammatory effect. You could have an impact in the gut-brain axis.
So let's get a little bit practical. Why you think that's a very beneficial way to go, and maybe what dosages you think would be the most impactful for people looking to improve their gut. We've always heard that omega-3s are great for the brain and the cardiovascular system, but there are emerging and very exciting benefits around things like the microbiome and muscle health. And today, we're going to talk to the scientific director within the Health, Beauty, and Nutrition Division at Group Burkham, and someone who has a PhD specializing in nutrition, lipid metabolism, and cardiovascular physiology. Her name's Dr. Amandine Brochot. And so welcome to the show.
Thank you very much for the introduction.
Yeah. So we're going to start with 3 quick questions, and then we're going to dive into your story and what makes you a very credible guest. But first, everyone's heard that high-fat diets are bad for our health and our microbiome. Is that always true?
No, because it's not only a question of quantity, but it's also a question of quality. You're right, some fatty acid, and notably saturated fatty acid, has been deciphered and described as deleterious for the gut microbiota, and this is one of the main topic of research of one professor in Belgium that is called Professor Patrice Cany, who has demonstrated that high fatty acids and obesogenic fatty acids in mice models, for example, have deleterious effect for the microbiota with modification of the balance and the right ratio of the bacteria. And based on that, it increased, for example, gram-negative bacteria that are known to have a pro-inflammatory effect. And besides on that, the fatty acids could also induce what we call a leaky gut, so make the gut barrier more permeable to some molecules, including the LPS that are pro-inflammatory. And he described that this, sorry.
No, I love it. Keep going.
This metabolic, what he called her metabolic endotoxemia, induce the cross of the LPS to the blood, which induce chronic low-grade inflammation that favor the insulin resistance and at the end type 2 diabetes.
Yeah.
And this is something that is really linked to the saturated fatty acid or not the good fatty acid.
Okay, great. And we're going to go there in a second. But I know that we shared this story. You studied kind of like animal nutrition, and you're a lipidologist. I mean, like, you know the nuances. So I'm wondering, in those saturated fatty acid feeds they were using in the mouse diet, what was the source of the saturated? Do you know? Because I have a few researchers on, and they're kind of going the difference in the type of fatty acids that they're using in these high-fat feeds. You're not quite sure?
Generally, they are coming from lard.
Okay, lard.
Yes.
Okay.
Mainly.
Okay.
Sometimes to complete, because you need sometimes to have a balance in order of the fatty acid sometimes, but in a low level you have also coconut oil that here to complete, but it's mainly from lard.
Okay, great. Now tell us, what are the beneficial fats? Just in a few sentences, you say the good fats. What are the good fats for the microbiome?
But it's mainly omega-3 fatty acid and the long-chain PUFAs, so polyunsaturated fatty acids. And this is true that in mice models, some researchers have demonstrated positive effect on those omega-3, not only on brain health and cardiovascular health, as everybody knows more or less now, but also they can impact positively the gut microbiota composition and alteration. So, and they do exactly the opposite of the saturated fatty acids with, for example, an increase of the diversity of the Shannon index, which is something that is generally looked at in scientific reports. And it was done in human, and more particularly in twins. And they have followed, yes, the omega-3 and DHA serum levels of those twins, and they have seen that with a higher level of omega-3 and DHA in the serum, you have a positive correlation with the microbiome alpha diversity and the Shannon index, which is quite pretty cool.
Really cool. So it's like a prebiotic.
Yes, it could be seen as a prebiotics, but prebiotic has a very specific also definition, so you have to reach the colon without a lot of modification to modulate the microbiota and also to have a beneficial effect to the host. This is the scientific definition, but actually it fits more or less quite well with the definition because we know that omega-3 have beneficial effect to the host. So it's quite interesting. And what they have also demonstrated is that they modify the Shannon index and they alter the composition, but they were also able to increase the production of short-chain fatty acids that are also fatty, like butyrate, that are very well known to have positive impact in the overall health. So yes,
Right.
this is one of the mechanism of action, but there are several other also.
And we're going to dive into those. That was beautiful. When you say polyunsaturated fatty acids, there's the omega-6 variety too. Do the omega-6s, like linoleic acid, do they have the same prebiotic and maybe short-chain fatty acid producing benefits? Do you know?
No, I don't think so. I do not have a look on that omega-6, but generally it's more, it's when I say polysaturated omega-3, it's fatty acid, it's for omega-3. And it's known that EPA and DHA both have been described in combination to have a positive impact on the composition of the gut microbiota and to have what we can call the prebiotic-like effect. Yeah, that's true.
Amazing. And last question before we get to your story. How many people throughout the world, in France and in America, if you know, are actually not consuming enough of these omega-3 fatty acids?
Oh, I think that it's more than a half. Oh, I didn't remember the data. I have seen it. We'll say most of people.
Absolutely. Yeah. And Harvard research said like 84,000 deaths in America alone every year. And then I've heard other researchers say about 75% worldwide, which is like, yeah, the majority. Okay. So tell us, how did you get into this? Tell us about your credentials and your training and what led you into this world of omega-3 fatty acid research.
It was because of just a search a few times ago, preparing only a previous podcast in my previous job. And I said, wow, omega-3 are able not only to improve your gut health, your brain health and your cardiovascular health, but also your gut. And the first study that I found was made on mice studies in which they made mice, they transplanted mice with feces in order to see if you can have not only a correlation with the effect of the omega-3, but also a cause and effect relationships. And they demonstrated that by transferring the feces, they demonstrated that the omega-3 can modify the microbiota through the production and secretion of a specific enzyme that is called the intestinal alkaline phosphatase, which has a role in mucosal defense. And by transplanting this, they identified this enzyme, in the YAP enzyme, and they observed that the enzyme were able to lead to a reduction of number of LPS producing bacteria, and thus reducing the metabolic endotoxemia. And this is the first time that I've seen an example of that directly on mice and with a cause and consequence relationship. And one hypothesis that the researcher after that made observing those results is that omega-3s are able to produce also metabolite, and one of them is resolvin E1, which is one of the SPMs that we discussed previously. And the hypothesis, the fact that this resolvin E1 could be directly responsible for the intestinal alkaline phosphatase expression, which improves gut health and the microbiota composition. So yes, it was quite pretty cool to have also those information and those data on that. And after that, there are some data that have been published in human research I have previously mentioned, like in twins and this correlation with the omega-3 in the serum and the Shannon index. And lastly, they also demonstrated that since the in utero steps, you could have an impact in the gut-brain axis, because they have made some studies in mice in utero, in which they gave a low level of omega-3 to the mother, and then after birth, the pups continue to have a low level of omega-3. And they demonstrated that this low level will have an impact on mice born fed a diet lacking omega-3, and after the effect, and they display anxiety and depressive-like behavior. And this implies also the impact of the gut microbiota.
Fascinating. And so you initially came into it wanting to study the microbiome, or was there a different entry point for you into this cardiovascular? You started studying cardiovascular research, right? And the omega-3s.
Yes. Yes, that's true. It was the beginning of the story, studying the effect of long chain or short chain fatty acid omega-3, so linolenic acid or EPA and DHA, in order to see if there is a difference of impact in mice on the cardiovascular function and the contractility of the heart. And in mice, the results were equivalent with the short-chain fatty acids and the long-chain fatty acids, but with the short-chain fatty acids only after 6 months of nutrition. After 3 months, it was in favor of the long-chain omega-3, but after 6 months, the shorter-chain fatty acid from linolenic acid were able to reach the same level of efficacy.
That's interesting. So are you someone who thinks omega-6s are good for the heart?
The omega-6?
Yeah, linoleic acid, right? Or are you meaning linolenic acid?
Linolenic from
Linolenic acid.
not
Okay.
the linoleic.
Got it. Okay, sorry, I was misunderstanding
my
that.
pronunciation, but it was all omega-3, but from the ALA, so alpha linolenic acid with an
Nice.
A, and not the linoleic acid, which is the omega-6.
Okay, so in other words, omega-3s, the longer chain, EPA, DHA, maybe even DPA, are a faster route to improved heart health, but that the plant-based forms, ALA, the plant-based form, was able to get there over a longer period of time, yes?
Yes, and it's easier to feed animals with linolenic acid because this is the one that you have in grass. So this is rich in linolenic acid, and in France you have some producers that are taking linolenic acid from the diet of the cows, for example, and that way they can improve the quality of the lipid profiles of the animals, including cows, including chicken, including eggs, and you have In animals, generally, they have a better way to convert linolenic acid, so the short chain fatty acids omega-3, to the EPA, DPA, and DHA. So it's a kind of way to improve the diet of the cows or the eggs or everything in order to improve the human health at the end. So yes.
I love that. And that was what my dissertation was on too. I love that we both share that. So now let's just back up for a minute because we're going to do a bit of a deep dive on the microbiome, but I wanted to find some terms first. So can you just tell anyone, for anyone who's new to the topic, what are omega-3s exactly?
The omega-3, they are lipids or fatty acids. They are lipids, but they have the terms omega-3 comes from the place of the first double bonds in the carbon chains. So when you start by the end of lipids, you count N-3. So this is the place of the first double bonds, because how define a polyunsaturated fatty acids? It's because he had several bonds, so unsaturated. And thanks to that double bonds, it gives also more flexibility into the membrane of the cells, because those omega-3 are able to reach whole cells and to give more fluidity to the cells and more deformability. So yes, in a nutshell, this is, in a chemical point of view, what are omega-3, and you can have it from vegetable sources, for example, and after that the long chains are more coming from fatty fish like salmon, sardines, and anchovy, and also omega-3 oil for people that don't like fish, for example.
Because cardiovascular research was your specialty, what would you say are the highlights of the benefits of omega-3s for your cardiovascular system? What exactly are they doing?
What are they doing, the omega-3,
for the
cardiovascular system? I know that there are a lot also controversy of the effect of the omega-3 on all the topics, but as I mentioned previously, it was also mainly due to the fact that the placebo is not really a placebo, because some of the time it's olive oil, and olive oil has also beneficial effects because they are not only good lipids, but also polyphenols and vitamin E that can be protected, especially for the cardiovascular parameters. But what have been described since the beginning by the first study by Dyerberg in the 60s, it was that people, the Inuits that were living in the Groenlands, they were eating a huge amount of fatty fishes and all those omega-3 rich foods. But even it was very high in lipid, they were really low at cardiovascular risks. But after some decades, they moved from Scandinavia in Norway and Sweden, and after several generations, people started to have the same level of cardiovascular disease than the people living in Sweden. So the researcher established that they were not genetically protected by cardiovascular risk. It was the food that protected them. This is the link between this move. It permitted the researcher to identify that it was not a genetic, but really the food that they eat that was very rich in omega-3. So the beneficial effect of omega-3 are generally linked also to fibrillation, atrial fibrillation, and all around the rhythmicity of the heart. And we know that long-term studies have been also associated with cardiovascular protection, with some cardiovascular risks in general, more or less.
Perfect. And before we get into the gut too, pro-resolving mediators, we did a prior episode, but for anyone who's new to you and didn't catch that prior episode, what are pro-resolving mediators? They're kind of a big deal, and they're going to relate directly to our conversation.
Yes, so these pro-resolving mediators are mediators that are synthesized by the body after the omega-3 have been able to reach the cells, because all cells are made on this double layer of phospholipids with two legs with fatty acids. And by with diet modification, you can change the composition of those fatty acids in your cells. And the more you have omega-3 in your diet, the more you will have omega-3 in your cells. And based on enzymatic reaction that you can have in your body, you can produce those pro-resolving mediators and these specialized pro-resolving mediators. They are highly beneficial because they have not simply an anti-inflammatory effect, but they have a resolution of inflammation effect, which is really different for just only anti-inflammatory effect. They are not immunomodulatory suppressive, not at all, but they can also stop the inflammation in order to come back to homeostasis, in order to prevent, for example, tissue damage and fibrosis that could happen when you have a non-resolved inflammation. Yeah. And this is generally what's happened when everything is okay, but sometimes due to genetic factors, because you don't hit enough omega-3, or just because you are aging, your body is less prone to produce those pro-resolving mediators. So you can find those molecules directly in some ingredient, and for example from herring roe, which is something it is described that they contain naturally these molecules, so you can bring directly the molecule and to have this resolution of inflammation effect directly, not waiting from the body produce them when needed.
Thank you for sharing that. And that's exactly why I'm so excited about the omega-3 product that we created with your company. But herring roe, what she's saying is pro-resolving mediators are like the grandchildren of these longer chain forms, EPA and DHA. Then they go to pro-resolving mediators, and then specialized pro-resolving mediators. And there's many classes of them, and your body can make them, but sometimes people don't make them well. And so taking them in a preformed way. And so herring roe is one source of that preformed pro-resolving mediators. Are there other good sources of them? Like would salmon, mackerel, would people be getting those from other fatty fish?
Not in a natural way. Yes, there are not a lot in fatty fish. You have some, but they does not reach a significant level to be in a natural way. You don't have a lot of those PRM, SPMs in fatty fish. You have, but not in a lot quantity. So yes, it's quite tricky to find naturally a source, a raw material that is a source of PRM and SPMs. And it's not really in a good quantity in fatty fish or in fish oil in general.
Thank you for sharing that. And yeah, that's exactly why and what they kind of do is, like you were saying, turn down the volume on inflammation that might be creating this chronic response that so many of people are suffering from today.
Yeah.
60% of Americans have these chronic, degenerative diseases, and a lot of them have this inflammatory component. So taking something that can help your body shut it off, it's a really powerful finding. So, okay, so now thank you for that. And I know we kind of touched on some of the microbiome benefits, but you can tell us, break that down. So we started with the high-fat diet in America and endotoxemia and LPS, lipopolysaccharide. Can you break that down and kind of define those terms for anyone who is new to this subject? What happens when we eat a high-fat diet exactly? And then how do omega-3s kind of modify that impact?
Okay. So if I have the answer for everything, I will be very, very rich, because for the moment we don't have all the clue, but we have some indices for that. But yes, the mechanism by which the saturated fatty acids are modifying the gut microbiota are not really well known. We have some clue on that. And sometimes it's just an observation. When you have too much saturated fatty acid, you modify your gut microbiota because you favor the gram-negative bacteria, which are pro-inflammatory bacteria. And they have also a lot of LPS. LPS mean lipopolysaccharide, which is a molecule that is on all the bacteria, not at all, but on bacteria that induce inflammation. So when you are eating too much saturated fatty acid or not enough omega-3 fatty acid, you can have a modification of the diversity of your microbiota. By doing this, you increase the bacteria that are bearing the LPS, the lipopolysaccharide, which is a pro-inflammatory molecule. And at the same time, the fatty acids are modifying the structure of your gut barrier by increasing the permeability, meaning that because your gut barrier is like a filter. It lets entering the things that you need to have to survive, but it stops also the things that your body is not doesn't need. So by increasing the leaky gut of the permeability, you permit some molecules to cross the barrier, including those LPS. And those liposaccharides can interact with your immune systems, which will increase the inflammation in your body, which is called the metabolic endotoxemia. And by increasing inflammation, modifying your immunity profile, you can create really the root of metabolic diseases. And for example, you favor the development of insulin resistance, which is the step before type 2 diabetes. So in insulin resistance, your level of glucose in the blood is normal, but your body is fighting against the fact that it needs to produce more insulin to decrease the glycemia. And one day, when your pancreas is not able to produce sufficient quantity of insulin to decrease your level of glucose, you have an increase of your glycemia and you can develop type 2 diabetes.
Thank you for that.
On the opposite, the omega-3 are doing the opposite because they have an impact of the microbiota that favor the diversity of beneficial bacteria. So you don't have all this never-ending cycle or this vicious circle. You have exactly the opposite. You have a better diversity, you have a better gut barrier function, you have more saturated short-chain fatty acid to be produced, so you can feed your intestinal cells with those short-chain fatty acids, so you improve your gut barrier function thanks to the omega-3 through the microbiota and through also the gut barrier function.
Yeah, that's really fascinating because every time we eat, we have an inflammatory response of some sort, of some magnitude. But what you're saying is the magnitude of that response can potentially be modified if you eat more omega-3 fatty acids. And then also keeping the tight junctions closed in our gut, right, can also prevent molecules like LPS from sneaking out and getting into the bloodstream, which then can increase the risk of insulin resistance. And insulin resistance increases the risk of type 2 diabetes, but also cancer, reproductive issues, heart disease. I mean, just all of the diseases that you don't want can be negatively impacted by a leaky gut and by insulin resistance and by that pro-inflammatory response that can't shut off. So thank you for that. That's fascinating. I wish more people understood that link. But can you tell me now, so when we're talking about that after meal pro-inflammatory response and pro-resolving mediators, is it Is that what's happening here? Is that what's helping it? You mentioned that there's some research around the gut and pro-resolving mediators. Is this tied into that, or is there a separate effect?
No, it could be included on that because some researchers were looking at how the omega-3 could modify also the gut, and they observed that some metabolite from the omega-3, so the PRM, SPMs, and notably the resolving E1, could have a positive impact on that. And one of the hypotheses is that this lipid mediator, the resolving E1, could be directly responsible for the enzyme that I have previously mentioned, which is the alkaline phosphatase. And this enzyme play a crucial role in gut mucosal defense, so the gut barrier function. So thanks to the resolving E1 that your body could produce or that you can have through herring roe oil, for example, you can have a positive impact on this enzyme that have a role in gut mucosal defense, which could which could lead to a reduction of this LPS producing bacteria and thus reducing metabolic endotoxemia, so this low-grade inflammation.
Perfect. And we talked about this a little bit in the other episode, but if you take a fish oil supplement, you're going to get a lot of different things under that umbrella, right? You're going to have ethyl ester forms, which are more like chemically modified to concentrate. You can have triglyceride forms, which exist in nature. You know, I think they're, maybe you can correct me if I'm wrong, the primary form in nature. And then you can have phospholipids. So is there a difference based on the type, the type of omega-3 fatty acid that you're consuming?
Yes. You're right. Generally in food you have triglycerides, and triglycerides for the body are known to have storage fats. This is what you have when you have in adipocyte the cells that are engulfed but with all the fatty acids. So on the contrary, the phospholipids are structural fats because they are making our cells, this double layer of the cells, it's phospholipids. So you have triglycerides that are more storage fats and phospholipids that are structural fats. So this is something that is different first. And regarding the effect, there are some data, not a lot, but some data that have demonstrated that when you have mice that are fed with long-chain unsaturated fatty acids and omega-3 long-chain PFAS, they have an increase in gut microbiota enrichments that is more marked than the one that you can have with triglycerides omega-3. So the forms also have a different effect on the composition of, the alteration of the composition of the microbiota. So it suggests also that we have a stronger beneficial effect with the phospholipid forms on gut microbial structure compared to the triglycerides forms. So there are some data, not a lot, but some of that, and other also that have been demonstrated in mice model that have been induced by an inflammatory gut thanks to a DSS. This is a DSS model, which is a model that mimics what's happened in IBD, so intestinal bowel disease like Crohn's disease or ulcerative colitis. And when people have tested the fact to give omega-3 to the mice to reduce inflammation via phospholipids or via triglycerides, they have a better effect on inflammation and on resolution of the disease thanks to the phospholipid forms of the omega-3 compared to the triglyceride one. So you can have an impact not only on the gut microbiota but also in the your wall, the wall of your intestinal cells. So both beneficial effects depending on the form of the triglyceride, of the phospholipid that you bring to your body.
That's amazing. Okay, so they're helping the gut barrier stay closed. They're helping the gut barrier produce mucus and stay healthy, and they're helping reduce inflammation. I've also read, are there metabolites produced when the bacteria create or consume omega-3s? Are there any other mechanisms that you think we missed before we get really practical by which omega-3s help the health of the gut?
Yes, I think that there are a lot. That depends also of of what we are able to find, because we find what we
Right.
know that exists, and maybe there are some molecules that we still don't know, that we do not have identified yet. And the first that we have here is the short chain fatty acids, the mechanism via these enzymes, and you have also some cross-feeding that exists between the bacteria. They use the, the, the molecules produced by one population of bacteria to feed other bacteria. And what we have discovered also in this DSS model and that we have published, not in link to the omega-3 but to prebiotic, is that some polyphenols are able to induce, for example, enzyme Q10 production by the microbiota, which is a well-known antioxidant. It's coenzyme Q10 that you can use notably in cream as cosmetics, but that your mitochondria needs to produce energy and have an antioxidant effect. But this is, for example, one way you can also improve gut health, but not only modifying the microbiota, but also the microbiome. And the microbiome is the genes expressed by the microbiota.
It's absolutely fascinating because the story so far has been about, what's happening in the cell membrane and the prostaglandins and cardiovascular, but to think that we have more bacterial cells, in our body and that they're modulating those as well. It's just like, it's a totally comprehensive effect. So let's get a little bit practical. Tell us, what are the dosages and the types? You've worked on a herring roe product, and it's the one omega-3 complex that we have. So it's herring roe and a few other fatty fish, but it contains those pro-resolving mediators. Can you just give us a few sentences about why you think that's a very beneficial way to go, and maybe what dosages you think would be the most impactful for people looking to improve their gut?
Yes, regarding omega-3, EPA, and DHA, generally it's 500 milligram per day of those two, EPA and DHA. You can reach 1 gram or even 2 or 3 grams when you have after a cardiovascular event, for example. And which is fine, which is cool also with the omega-3 is that they are mandatory all along your life, even before. As I mentioned, in utero, the baby already needs DHA for the growth of the brain and for the growth of all the nerves and everything. So, and during breastfeeding also, you need to have omega-3. And if you are not breastfeeding but in formulas, you have also linolenic acids, and you have in Europe health claim regarding linolenic acid, so the short chain fatty acids, for the brain development of the baby. So you need the beginning of the chain of omega-3, but also the EPA, DHA, the end of the family of the omega-3. So all are necessary for the brain health of the baby. And for kids, you need also for memory, for a lot of stuff when you are pregnant and while you are aging, with the prevention steps in order to prevent some eye disease or brain disease, or to prevent cardiovascular health. And yes, generally it depends. Sometimes you can have a different ratio depending of what you want to tackle, brain or heart. But in a nutshell, just to be simple, take omega-3, and after that, if you want to be very focused on one EPA on DHA ratio, you can. But first start to take omega-3. It will be helpful in every way. So yes, it's 500 milligram per day to start. You can reach 1 gram per day for the particular population, for cardiovascular prevention, for example. And after that, for PRM and SPMs, we have some internal data on the impact of these PRM and SPMs in human health, and more particularly in skin health. But for the moment, if you stick at 100 milligram per day to 1 gram on EPA, DHA, with it's 300 microgram per day, more or less, of PRMs. So you can have an additional beneficial effect, notably on resolution of inflammation.
Perfect. I love that. So fatty fish, a supplement with, EPA, DHA, at least 500 milligrams, maybe more. And in the phospholipid form, if you could find it, triglyceride phospholipid forms would be the most preferable. But you can also get some from food, right? Greens has that alpha linoleic acid, like you said, some vegetables, flaxseed. Do you think, so everybody start where you are. If you're not getting omega-3s, absolutely 500 milligrams, EPA, DHA. But what about the omega-3 index? Do you measure that as a omega-3 researcher? Are you familiar with that? Would you think getting to a certain place is advantageous for the microbiome too?
Actually, we have this omega-3 index for the red blood cells, you mean?
Yes.
This is something that you can measure in order to have, but you have really to have a precise and to find the right doctor and the right lab in order to be sure of the interpretation. And it's also an easy way to know if you have sufficient omega-3. So yes, thanks to the red blood cells, you can have access to that ratio. And if you have the right doctor, you can have what I mentioned previously, the way to fine-tune which are the omega-3 that you are the most lacking. So you can choose to add more EPA or more DHA, and to choose what in a dietary supplement, and you can have those kind of ratio that are also different from EPA and DHA. But yes, this is an easy way to measure your level of omega-3. And this is also something that have been used in clinical research in order to predict also how to link this omega-3 index to the risk of cardiovascular diseases or other diseases. So it could be used in an everyday analysis in order to see where you are. But it is also something that is used in clinical research in order to make a link between this ratio, this index, and the risk that you can develop a disease, for example.
Perfect. Thank you so much. And last question is just, is there any downsides or negative impacts of omega-3 supplements or negative features of most omega-3 supplements on the market that you'd like to put on people's radar when they're looking for something to take if they're supplement?
When you are taking omega-3, just don't look at the quantity of the fish oil that you have, because sometimes it's mentioned that you have 1 gram or 2 grams of fish oil, but sometimes you have only 30% of EPA and DHA. So be sure that for 1 gram of fish oil, you have around 400 or 500 milligrams of omega-3 inside. So this is one thing to pay attention of. And sometimes with very high level of omega-3, some old studies have been linking this high level with a risk of bleeding. But it's very high, more like 5 or 6 grams a day, which is something that it will more or less never happen now if you are taking a dietary supplement and just 1 gram a day. It's okay. But just look at if you have more or less 40 to 50% of the fish oil that are omega-3.
Great. And then only because you're a cardiovascular researcher, I've seen like higher levels associated with like a increased risk of atrial fibrillation. Is that something you're worried about? Do you think that's a concern? I've heard about like over 4 grams a day and maybe the ethyl ester form. I don't know. I just thought, I wonder if you have some thoughts.
Just be honest. We are thinking, okay, if I eat 4 grams a day of omega-3, I will have atrial fibrillation, but let's eat some saturated fatty acids today. It's even worse.
It's a lot worse. Yeah. So let's put it in context, is what you're saying.
Let's have a balance between what you are thinking that it's dangerous for your life. To sit every day as I am, it's more dangerous for my life and for my body.
I love that answer.
So yes, just to be balanced and just be focused on what is very dangerous for your body and not to reach 4 grams a day of EPA or DHA. It could happen, and I'm not saying that it is impossible, but there are far more dangerous things that we are eating, drinking, or breathing.
Right? Okay, perfect. Well, thank you, Dr. Brochot. This has been amazing. And you can tell people what's next for you, or any famous last words of wisdom, anything, or where they can connect with you and learn more about your research. So let us know. Tell us.
Just that I'm going to work more and more on polyphenols, if it's your questions, because this is something now I'm really excited about. And the combination of the effect of polyphenols and omega-3 will be, in my sense, something that could be really grateful for the body and for the research. And we have still a lot to know and to understand with the combination of that two elements that we can have in your diet. And don't be afraid of eating a rainbow every day in all your plate.
What is it?
A rainbow of colors.
Rainbow.
Put colors on your plate, because this each color is a polyphenol with specific effect. So just add the good oil. Don't be afraid of good fatty acids, but maybe more careful about sugar, which is something that it's quite things that everything that we have, the food that is transformed is not only rich in fat now, but also in sugar, and there are very deleterious effects on that with children that are coming with fatty livers of NASH, which is something that never happened before. So yes, and I hope that in the future we will have good news on the effect of polyphenols combining with omega-3 and phospholipids, PRM and SPMs.
Okay, well, I'm excited for that research, and thank you so much. This has been incredibly enlightening, and I'm so grateful for your friendship and your research.
Thank you very much.